See children, here we are going to study a new phenomena in physics which is dispersion. Okay, now all of you know what is refraction. So dispersion is also a kind of refraction. Now let us see what is happening here. We know this is a glass slab. When light is hitting the glass slab, what will happen? Instead of going straight, it will bend. It will bend. Okay, so this is what refraction. The same thing happen in the case of a triangular prism. A white light hits the prism. Instead of going in the straight line, it will deviate its path. Okay, it will move. It will not go in the inside the triangular prism and outside the prism. The light will move in different paths. Here also, outside the glass slab and inside the glass slab, light will move in a different manner. That we know. Now we are going to do the same experiment with white light. Okay, white light is hitting on a triangular prism. Okay, definitely we know refraction happen. Instead of going in the straight line, refraction happen. But we can see a magical phenomena happen here. You can see at the other side, you can see so many colors. Instead of one light, at the other side we will get a mixture of light. And what all light you can see here? V stands for violet, which is the colors of a rainbow you can see at the other side. So violet, indigo, blue, green, yellow, orange and red you can see at the other side. Okay, so when a white light hits the prism, it will separate or deviate into component colors, or it will divided into different colors. Such a phenomena is called dispersion. What's this? What's the reason for this dispersion? And before that, from here, from the figure itself, you can see which light is deviating more and which light is deviating less. Deviation means valavu. So the violet is deviating more, and for the violet, the bending is more for the violet, and red has the least deviated. So the bending is very less for the red. So the reason for this dispersion is that dispersion means the splitting of white light into such component colors on passing through a prism. Okay. Now, not only passing through a prism, that we will discuss later. Okay. So this phenomena is called the dispersion. And in the dispersion, what all reason for that? Usually we are for the CBSE board exam, they are asking what's the reason for dispersion. Reason is that we know violet color has a speed which is very less. So less means I am just putting the arrow mark downward. So for the violet color, speed of the violet color is less. So what happens actually reversely, refractive index of violet will be more. Okay, so when speed of violet is less, refractive index of violet will be more. Because of that, violet is deviating more. So there are two reasons for that. Violet has speed less. Speed of the violet color is less. So refractive index of the violet is high. Because of this two reasons, violet is deviating more or bending more. Okay. Now what happens reversely? Refractive, in the case of red color, all the phenomena will reverse. So red color, speed is more. So refractive index for the red is less. So refractive index and speed both are inversely proportional. Okay. If for the violet color, speed is less. So refractive index is more. Reverse is happening in the case of red. So what happened to the red? Red is least deviating. I think it's clear to you. So dispersion is actually splitting of white light into component colors. Now reason is mainly because of difference in speed and the refractive index. Actually we know white light is made up of the mixing of all these colors. Okay, so when we are passing the white light to prism, they are dividing them into the component color because of all this. Another topic which is there in your 10th standard CBSE texts, why the stars are twinkling. From here in this chapter we are going to disclose the reason for many of the natural phenomena. So here we are going to disclose the reason for this, why stars are twinkling. But the planets are not like that. It's not twinkling. We are not feeling the planets are twinkling. So there are two reasons for that. And one more thing I want to explain before getting to the topic. I want to explain this term, which is apparent positioning. Apparent positioning means I already explained you what's the refraction in the first chapter. If you are dipping a scale in a glass of water, inside the water, that scale will have one position, or outside the water, that is air, you can see the scale is bending. Okay, so one of the real effect of refraction is position will change. Okay, the effect we can feel because of refraction is the position of the sub-object which undergo refraction will change. That is what apparent positioning. Actual position will differ. That is what apparent positioning. Okay, we can't see that object in its actual position. That is what apparent positioning. So stars also have the same problem. Light from the star is undergoing refraction so many times. Because of that, we can't see star in their actual position. We are seeing their apparent position. Okay. Now the second reason is that amount of light from the sky, from the stars, amount of light entering into our eyes from the star is also changing, keeps on changing. So because of this two reasons, stars are appeared to be twinkle. Main reason is refraction itself. Okay. Now why planets not twinkle? Planets are the light which is coming from the planet. Almost all light are reaching in our eyes. There is no much fluctuation or deviation or decrease in the amount of light enter into our eyes from a planet. So that is what stars appear to be twinkle, but the planets not appear to be like that. I think it's clear to you.